So good afternoon, good day, everybody, and thanks for this opportunity. And I'm glad that I'm being part of this event. And then we'll be talking a little bit about SecMLOps. We have all been going through MLOps everywhere for the last 2 days. And then tomorrow also we are going to discuss more on machine learning operations. But SecMLOps, why did we even, does anybody know about SecMLOps as a framework, or is there something new to you? Anyone? All right. And the motivation behind this talk was the main reason is at S&P Global, when we deployed machine learning projects at scale, and then when we deployed them into production, we were getting some questions like, from compliance and audit, and how do we take care of them? So that pretty much motivated me to take a look at this. And then, by the way, what is SecMLOps in a nutshell? I'll just give a brief definition about what I think SecMLOps is all about, and then what are the current challenges, that the industry is facing in implementing the SecMLOps. Then I'll also go into, if you have those challenges, you need to have those solutions as well. So, what are those possible solutions at the organization level and also at an individual project level? Then, after going through those solutions, I will briefly touch upon what is the current state in this industry, how companies, both startups as well as the bigger enterprises, how are they implementing SecMLOps, and what are the various stages that are out there. And then finally, based on my learnings, I'm going to delve deep into the SecMLOps framework, and wherein we are going to talk about injecting those security principles in the pipeline. And then finally, at the end of the day, it's all about the learnings that I got by implementing these features. So motivation, we all know that MLOps has evolved in the last 3+ years, big time. And a lot of these startups are getting those seed B and seed C funding at ease. And the interesting thing is organizations are pretty much faring when they are trying to stick to a particular MLOps vendor. They think that what happens to my security? What happens if I stick to this particular vendor? Is my data safe if I start giving the data to a vendor, or when they are going to manage my machine learning models? How does that work? Whether it's going to be on cloud or if it is going to be on their proprietary platform. And in addition to that, the customers or the consumers, they are also asking us, can you please give me the records that that you're using as part of giving those recommendation models? For example, I wanted you to make sure that you're not violating any of my personal data. So we are getting pressure even from the customers, and we also need an ability to the customers rather they need an ability to delete some of their personal data. We are going to look at some of the laws which have been out there, both in terms of GDPR as well as in the United States. And some of those laws really require the customers for them to to delete the data. And technically, when they have an option to delete the data, the customer should also have an opt to. They must have an option to opt out of using their personal data. And there are lots of regulations which are coming in, and that's pretty much is the motivation for this present talk. And if you are not going to comply with those regulations or those audits, the very fact that the cost to fix the security vulnerabilities after the fact that the model has gone live is extremely costly, and a lot of productive hours are being lost in terms of that, in terms of firefighting some of the security questions. Let's look at some of the broader security headline news. We all know about it. Everybody is reading about it in LinkedIn or in one form or the other. AI systems that produce biased results have been making these headlines. For example, I just read an article a couple of weeks back wherein they were talking about deep sloth, wherein researchers are pretty much finding out ways to exploit the neural networks which are running on edge devices. Usually neural networks, when they run on edge devices, they run for a shorter period of time because they have a quick exit strategy. but exploiters are making sure that they run for a longer time, and then that is going to break the inferences that are happening on edge devices. And there are a lot of adversarial attacks which are happening both on computer vision and then on NLP models. We all know about the classical problem that the automated driving cars had, wherein you go and then go into look into the stop sign, and then if you make a digit there, the automated vehicle thinks that, like, it's a speed limit, and then, like, it goes past the stop sign. That's a catastrophic effect there. And we also have seen where machine learning models are leaking the training data which have been used to train those models. We'll go a little bit deeper into that as well. And some trivial reports, we know that by 2020, since 2020 rather, most of the data, like, from the corporate world, including the bigger organizations, they're all on the cloud. So that pretty much goes back to the security out there. And then 79% of the US consumers, according to research, they have said that they are pretty much worried about how organizations are using their data. Are they exploiting us, or are they making a real good use of their personal data? That remains to be seen. So with these security headlines, I just listed only a few of them. Let's look at some of the data privacy laws. We know about GDPR. It's all about the two letters DP is more important there. It's data protection. And the R talks about the regulation there. So by the sheer definition of GDPR, it's all about general data protection regulation. So regulators are going to come back to you if you're going to violate any of their personal data. And in the United States, there are a number of laws that have been passed. I've just appended the list here. I'd be more than happy to share with you all. But I'll just highlight some of the three of them, which meant something to me. The Colorado Privacy Act. This is pretty much about when you're deploying machine learning models to the consumers. The consumers, they should have the right to either delete their personal data, which I covered during my introduction section. And then the second one, in the state of Connecticut, they passed an interesting law wherein they are planning to incentivize companies who are employing good security standards as part of building their machine learning projects. And this is interesting because this will protect the organizations from any of their lawsuits that are going to come through, and the state is giving them that kind of a feature there to protect those organizations if they are embedding security principles according to those standards. Then we have the California Privacy Act, which says that after January 1, 2022, the consumers or the customers should know what kind of personal data are the companies using, on their behalf. And there are a lot of laws which are coming around, the Social Media and the Privacy and Consumer Rights Act. So that is going to give the users more control over the data, which is needed. So what does it mean for ML? So we talked about machine learning, we talked about security there, but what does it mean? So in machine learning, we are always thinking in terms of three things, the velocity of the data, the speed with which the data is coming, the volume of the data that is going to come in, and then the variety of the data, right? It could be a structured data or an unstructured data. It can come in myriad of forms. And even though we are training our machine learning models on humongous amount of data, when you start working on a machine learning project, we all know that we start with a subset of data, and then we slowly start expanding with a bigger data set. But if we are not careful in addressing the privacy concerns, even with this limited data set, most of the time we are pretty much focused only on getting the model right. But we are missing out the most important piece, which is, I'm just having only 1,000 rows of data. I just wanted to make sure my model works, my POC works, my hypothesis works. But what about the privacy there? What about the security concerns there? Even in that 1,000 rows of data, that's so important. And one way or the other, whether we like it or not, the data that machine learning models use, it has some kind of a private data, some confidential information is hidden there. It's latent, and we got to poke our eyes into it and then to start unraveling it. And a recent paper by Liu et al. On the security threats and defensive techniques, it talks about various attacks, the integrity attack, or the availability attack, or the privacy violation attack. The privacy violation attack meant something to me. It means that if eavesdroppers, like if they can come, or if those nefarious actors, if they can come in and then look at the training data and then extract those confidential information, you're done. It means that you got to really protect your walls out there. So we saw about those challenges there. Now let's look at MLOps. MLOps, in my opinion, it accounts for rapid science, experimentation, building and deploying models at scale. Everybody has got their own definition, but in my world, or the way in which I see MLOps, is all about a framework or a discipline which enables the data scientists, the machine learning engineers, and it empowers them with the right set of tools so that they can generate the necessary business outcomes that are needed for your organization there. So now, okay, we talked about the security, we talked about the challenges there, we talked about the headlines which are out there. So then what is SecMLOps? How is this going to come in? So the way in which I think SecMLOps is all about, I think everyone here in this room might have a different definition, but in my opinion, it's about how machine learning pipeline is not a conventional pipeline like a typical software engineering project. You don't have a build and then you do a deploy and then you do a test. It's not that. You got to go through probably your feature engineering, your model selection, your data cleansing will be completely in a different programming language. Then you will have your feature extraction in a different language. Your model training can be in a different framework. And then, of course, model inferencing. It's not a conventional pipeline. So SecMLOps to me, the way in which we all think rather is how do we embed those security principles in every stage of those machine learning pipeline? That to me is SecMLOps. So what does that give you? It helps you to build machine learning models at regular cadence. You can ask me, without SecMLOps also we were building machine learning models at regular cadence, but there is a catch there. The catch is you are embedding security in each and every stage of those pipelines, and you can be confident that the data and the models, the insights that you are generating is of utmost importance to those customers, and then you're not violating any of those principles there. And the most important advantage which I see here is the data science team, the machine learning engineers, or the visualization experts who are working within that team, they are self-sufficient in adhering to those standards. So they start with the security-driven design thinking right from the outset. So it's not that they are firefighting after the end of the fact. They are taking those principles much earlier. So, what are the current challenges that we see in the current industry? Some of those challenges are more code is being shipped, a lot of startups are coming up, and with the pandemic and with post-pandemic, people are not paying more attention or any attention to the application security. So that is going to put the businesses at risk. You can generate those important prediction models, but if you're not putting those AppSec policies, that's a bigger risk there. And then with the shift to work from start paradigm, you can work from anywhere, in this world. And with that kind of a mindset, you don't have a centralized entity which is looking at the security aspects of your machine learning models or even your training, and that's a bigger problem. Then, so for bigger organizations, there is a centralized application security champions who might not have enough understanding about how machine learning models work, and then finally they come down and then they chase the machine learning engineers, and then they act as intruders. They say, you know what, you got to adhere to A, B, and C, but they don't know what A, B, and C is all about because they are not machine learning engineers there. That's another problem. Then the way in which I see here is when security becomes a centralized function, it becomes a little bit of a challenge there because you have in conventional organizations, you have an application security team that is sitting and reporting into the CSO, the chief security officer. But what happens there is they do not understand how exactly it will weave into the machine learning pipelines. So that's a bigger problem there. And with go-to-market and digitization, security teams, as I said, they are always seen as intruders. One is they don't know what they need, but they are just coming as intruders. They're not acting. They are pretty much they're not acting as a catalyst or nourishers. They're acting more like an inhibitor there. And then most of the security policies have pretty much lived outside the machine learning world. And then when those audits or when the compliance requirements come, you're taken aback. So what are the possible solutions that we can think of? The way in which I thought about is you can think about some of those solutions both at the organization level and then at an individual data science team or the project level. So it's my wishful thinking. Some of my colleagues who are here might also adhere to that. I wanted a situation where we can have a decentralized security function, but that should be closer to the machine learning teams. I'm not opposed to having a centralized security team. That is needed. The main thing is if you have machine learning teams spread across your company, it is important that you have those security teams staying very close to those machine learning teams. You can have one or two engineers working within those teams there as well. And once you have without a proper MLOps framework, SecMLOps will not even fly. So you should have a proper core MLOps framework to begin with, and then the SecMLOps, that is happening, that's out there, in those individual pockets of data science teams within your organizations, they can continue to evolve, and then they can share those best practices out there. Moving on to the other side of the spectrum, what happens if I have a centralized machine learning team which has a well-defined MLOps, then it becomes a strategic initiative. You have a security champion who is going to report into the CSO, and then he is the one who is going to guide those security principles across your portfolio. And with this, you have taken care of SecMLOps or the application security champions being, you're moving away from being as intruders, and you are enabling them to be a part of the machine learning pipelines. And so at the organization level, these are some of the things, but at an individual, at the data science team level or at a project level, there are some things which I think is important. For example, the data science teams, when they're building those machine learning projects, they should technically move away from those ad hoc requests asking them, can you please come and then do a security evaluation on my project, as opposed to think about a situation wherein they say, you know what, I need to call this API, it'll come and then scan my code, and then I'm done with it. It'll generate the reports for me. Wishful thinking. And with a machine learning pipeline, we know that it's extremely complex, and there are so many stages out there. Even if I can go down to the most granular level, if I can automate that piece, and then if I can embed those security principles, the one that I was talking about, if I'm training with just only 1,000 rows of data, if I can embed those security principles even at that stage, that is so important for me. It will come and help me big time. Then SecMLOps, as I said, it's all about injecting those security principles into the ML development pipeline and setting up those vulnerability scans and then enabling those security standards as part of your continuous integration and continuous deployment pipelines will help you to achieve the standards that you're going to set for your team as well as for the organization. And the most important thing is it's not only important for you to have those security principles in your lower environment or in your dev or UAT stage. It needs to be available across every environment, across UAT stage, parallel production or production, across wherever that you're deploying. So those security architecture principles need to be embedded there. Now moving on to the data science teams. So this is at the organization level. So at the project level, so what should the data science team do? So they must be familiar with security-driven design thinking. They should know how do I execute the set of instructions that I need to execute to make my code robust. And they should also have a trade-off. In what circumstances do these standards apply? In what circumstances do these standards do not apply? And then you'll have to go through who takes care of owning these security defects. Let's look at some of the stages of security in the current industry, right? You can have the beginner stage where people are just getting started. Then you have matured organizations where you have some kind of security principles embedded. Then you have advanced, where people are getting a little bit more hands-on with embedding security even after the model has gone live. And then you have the pro. The pro is all about the professionals, wherein security is embedded even not even when you're writing the code, even after the model is getting deployed, you have those runtime vulnerability checks that's happening continuously. So the beginner is all about conventionally in startups or even in bigger organizations, you have the data science team writing the code. Code is sent to QA for some functional testing, then the production rollout happens. What is the problem here? What is the outcome? The outcome is there are no security checks. They rarely happen. And even if the security checks happen, it is usually an outside security team does those reviews. And the focus is only on the code, and they forget whatever that has gone in the pipeline, and the fixing is pretty costly here. What is matured? Matured is about the data science team, they write the code, sent to QA for testing, but before it moves into the production, you have a security check done by a centralized team. And then after the models have gone live into production, you have conventional twice a year vulnerability testing or stress testing as part of a firm-wide effort. What are the outcomes here? Again, you have the staggered release of those models. Why do I say staggered release of the models? The reason being, you're not embedding those security principles there. So same problems that you saw during the infancy or the beginner stage will still exist here. So the time it takes to fix those security defects, it is still out there. Advanced. Again, same cycle. The data science team write the code. Security reviews, they happen after the code is written. As and when the code is written, security checks happen. QA tests this out. Then the security checks are done by a centralized team. Then you have a prod rollout. Then you have the twice a year penetration testing or vulnerability testing by the firm. And with this, what is the outcome? It's improved from the preceding stages, but we are still exposed to there are no runtime security checks on open source vulnerabilities, right? The cost to address this and fix is a bit less compared to the previous two stages, but it is much better. Then looking at the pro, data science team again, they write the code, dynamic security reviews happen as part of the plugins, as part of the IDEs that you're using. It could be automatically plugged in. Quality checks happen, meaning the security testing is embedded as part of the QA test. In none of the preceding stages, you had security testing as part of QA. But here, for those in that pro stage, you have security checks embedded there. Then UAT, prod, pre-prod, or parallel production, all that environment. There is no environment disparity at all, and they have the security and controls in place there. Then production gets rolled out. Then the most important thing between the prod rollout and the quarterly penetration testing in this stage is about the continuous vulnerability assessment of security vulnerabilities, rather continuous assessment of those security vulnerabilities when the models are continuously running in production. That's where the key thing is. Outcome is go-to-market is faster, models are more secure, automated runtime security checks are happening after when the model is being served, and adherence to compliance or audits is just yet another activity. You can just pull in something, get those reports, and then you can send it to those auditors. So we know about MLOps. So now that we saw the challenges and then we saw some of the possible solutions, I wanted to digress a little bit into the MLOps key drivers, because this will act as a fuel or a funnel into the SecMLOps framework. MLOps key drivers are about multiple things: resource management, experiment management, creating those machine learning pipelines, or monitoring or deploying those models in production, or how do I schedule the various stages in a machine learning pipeline. And then at the end of the day, am I piggybacking on a vendor or an analytical platform that is scalable? If it is scalable, then those are all my set of drivers. For some organizations, they will choose the drivers which are so important to them. But for some others, or even for startups, they can choose whatever that is so important. It depends upon what they need. If you look at a conventional ML system architecture, we have the raw data, we validate the raw data, we cleanse the raw data, then we transform the data. Once the data is transformed, we split it into the classical training and test split. And then with the data analysis and preparation, once we have the data, we use the data to use it for your model training. And we use the holdout set for model evaluation. And once we are satisfied with those models, we have a model tracking service which tracks about what are all the various experiments that have been run. And then the output from your models are again generated. The models, the output, or the insights that you are going to generate, they are essentially going back into those green box that you see there. So if I were to decompose this is how the architecture would look like, right? At the top, you have the data lake. So the data lake will act as a source as well as a sink. You can ingest the data from the data lake or from a centralized repository where you have strict governance there, and then the transformed data or the curated data or the engineered data that you create is again fed back into the data lake. Why? Because other projects which might need the data, they don't need to go through the same problem. You have already done the cleansing part, so other projects can start using the data. So that is why it is advantageous for us to push the transformed or the curated features into the data lake. And even the model training and the insights that you generate, it again goes back into the data lake. It acts as a sink there. And once it's out there in the data lake, you can just spin a SageMaker instance and then get it out there, or embed them in customer analytics workflow like Tableau or Instant Analytics, or you can just ship them as a flat file with S3, right? So at the end of the day, there is a version of the data that you are generating out there at every stage. So with those drivers and then with that system architecture of ML components, now how do we think about implementing SecMLOps for data science teams? Start with those MLOps drivers, those resource management, experiment management, scalability, ML pipelines. All of those things are so important. So start with those MLOps drivers. Understand those ML system components, the data lake, the transformed data, the curated data. Where exactly is my data moving? And where exactly is my data getting stored? Where am I generating those insights? Take a look at those system components. Then plug in security checks at each and every stage of the pipeline. It could be manual, it could be automated. Conduct a security review sooner than later by security champions. Again, it could be localized security teams which are closer to the ML teams, or it could be a centralized security team. Either way, it works fine. Then address the findings before moving on to the next stage in the pipeline, because if you're not going to fix those defects, it is just going to bleed into it. Then the lesson that I learned, or that we at S&P Global that we learned, was we wanted to shoot for the stars, so that we can land on Earth. So we wanted to aim for the pro stage, and then finally we ended up landing in advanced. So, or if you start at pro, you can land at mature, or you don't want to be at the beginner stage at any point in time. And when you start managing multiple projects and when projects increase, the most important thing is you got to embed these security principles for each and every one of those projects, stitch them together. And we know about this last statement: when things go wrong, the devil catches you if you're not alert, right? So when you think that, oh, my models are secure and then everything is running in production, for all you know, you might be waiting for the devil to catch you there. So be alert. Then finally, revise those security guidelines and rescore those pipelines every year. And as part of your continuous feedback that you're providing, the pipelines have to be rescored every year. So how do I implement the SecMLOps framework? I was just waiting for this stage. So how do I do that? So in terms of compliance and audits, right, they're not going to ask you about, oh, did you do this here? Did you do this here? Because the ML pipelines are not conventional pipelines. It requires a different mindset. So it starts with the data ingestion. So if you really looked into the ML system components, you have the data lake there. We are sourcing the raw data, or we are sourcing the data from which is transformed in some way or the other. So whether we are sourcing the data from cloud, or if it is a transformed data, or if it is a raw data, we'll have to look into these various aspects. Am I sourcing it from a flat file? If I'm sourcing it from a flat file, what are my ACLs? Or where exactly is my file stored there? Or if I'm pushing, or if the source system is pushing the data, or if I'm pulling in the data, where am I pulling it from, or where are they pushing it to? It cannot be that, they are pushing into some kind of a database there. Has it gone through those quality checks? What about the SLA? What about the governance there in that data? And then when you're accessing data from let's say from a cloud storage, how are you accessing the data? What are those keys? What are those credentials that you access the data? Are these ephemeral? Are they going to live for a shorter period of time, or are they going to be permanent? If it is ephemeral, who rotates those keys? You cannot say that, the data is living in a Redshift database and there is a centralized cloud engineering team who manages that. But you got to be mindful of who rotates those keys periodically. And if it is a permanent data, where are you storing those secrets? The secrets should be known by someone. Who's that someone? Who should be that in your organization? These are the questions which came out of those audits. And that's where we are expanding on this today. And if you are querying the data via an API, is that data, the data that you're querying, is it universally discoverable? If it is universally discoverable, it means that it has gone through a lot of quality checks there. So you'll be better off in that space. And when you are querying the data, be very careful about the PII. There is some amount of PII in every data set that you ingest. Is it anonymized or is it de-identified? And how are you implementing the zero trust? Never trust anybody. That's the rule of this world now. So don't trust anything. And even with the machine learning systems, it becomes so important that how do you implement zero trust? If I don't have a necessity, even though I'm part of a bigger data science team, and if I don't have a necessity to look at what data is my recommendation model needs, I should not even be looking into that data. And then look at the data contents. Okay, I have this data there, everything has been taken care. Is it representative of the population that you really wanted, that your models need to train on? For example, if you're generating your recommendation models, you can see that you can generate Poisson feedbacks into the system, and then your models will start training on Poisson feedbacks, which is again a catastrophe there. Then how are you addressing bias? Then moving into the data engineering, you have to look at the code to clean the data. Are you cleaning the data in your conventional notebooks, or what is the project structure that you have there? And if you have a proper project structure with a machine learning project structure out there, where are they kept? And where are they running? Are you taking this code and then deploying them as jobs in Databricks and then running them in an analytical platform? And even if you're running that in an analytical platform, how are they even accessing the data, right? That's how are they even accessing the data that is needed for those machine learning models that you're running in an analytical platform? Then you talk about, okay, now that my code is out there to clean the data, to transform the data, it's running out there. What are those mandatory quality checks? We think for Python-based projects, those who have all been working in Python, you got to run your BLACK, run your ISOT, run your PyLint, run your Fortify, which will take care of those vulnerability scannings, run your white source, which takes care of open source security vulnerability assessments. That becomes a key when you are in the pro stage, wherein when the models are running live, you can do those vulnerability assessments at runtime. And then SonarQube, again, talks about the code coverage. That's more about cleaning the data. What about the features that you have generated? Where are you storing those features? Are you using a feature store there? And when you are storing those features, when you're artificially creating new features, did any new PII pop in? For example, you might be ingesting some data from a source, but then you'll be augmenting it with some additional data which you have not accounted for. As a result of that, some PII could have popped in. Did you take care of that? And is the data discoverable across the whole spectrum? And how will this enhanced data set, the features that you're creating, how will they work outside of the data science team? That's about the data engineering. Moving on to the next stage, you saw the data ingestion, the data engineering in your ML system, in your ML system architecture. Then this is where the real meat is, where you train those models, and then you do those experiment managements. So some of the questions which we have been asked and which came out of those audits was, which machine learning framework are you using? Is it open sourced or is it licensed? Where are you getting that packages out there? And what kind of a distributed compute are you using for your models? Is it in Databricks? Is it any scale? Is it Domino? Or is it SageMaker? You name it. They are going to ask you those questions there. And when you're using the models, when you're training your models, is data streaming needed for this? This is an important question when it really comes down to compliance. Compliance, they come up like with binoculars, and then they zero down on this aspect of it. If you are using data streaming, that's a separate talk that I need to discuss, because it's very involved there. When you talk about data streaming, because you got to look at the security at both at data at rest and then both at transit. Then where are those experiments logged? And can I query those experiments via a CLI or API or a web? Who can query those experiments? Should my data science team should query, or should someone else need to query that? Then finally, where is this? Okay, I have this data. I have taken care of the security vulnerability scans. I've run my 45 white source and everything. I've created all these wonderful documents out there. But where is the lineage there? How do I know that, I was using this data, I used it for this training, and then these are my insights, and this is what I'm serving to the customers, both internal or external, or this is how I'm serving via an API or batch inferences. So you need to have that entire lineage there. Then finally, you need to know where exactly is your model registered, right? If you don't know where your models are registered, it becomes absolutely impossible for you to debug any model there. I don't think so we'll ever go back and then debug a model, but registering a model is so important when it comes down to compliance. This is very similar to what we have in DevOps. It's no different, except that here we are registering models here as well. In terms of deployment and monitoring, we know about API-based interfaces or batch or streaming inferences, or you can create them as embedded insights. Then you have a separate framework called as a drift detection framework. So for API-based interfaces, who are all accessing my endpoints? What are the entry points to it? Is it backed by an API gateway so that there are no poison requests that are coming in? Am I throttling those requests which are going into my inference APIs which I have created? And how do I handle those requests? And when I'm generating those results via an API query, are my results exportable? If my results are exportable, am I making sure that I have taken care of de-anonymizing any of the confidential information that should not leave my company? That's out there. Then with batch and streaming inferences, it's all about where are my insights stored? Am I storing it in S3, or am I sending it as a flat file, or am I just storing it in HDFS? Where are they stored? Or what are the downstream systems which will leverage this data? Again, it's not only your job is not done when you deploy your machine learning models. You'll also have to think about who's going to consume my data down the line. And with embedded insights, you can talk about, am I embedding it in a widget, or is it integrated with any conventional CRM tools? For example, you can take your insights, you can embed it in Tableau or Instant Analytics, but they need to know what kind of access patterns that they have to access the data or the insights that you're generating. Then finally, the drift detection framework. I think there are a lot of talks here, and then we also have some exhibitions out there, the drift detection framework. That is so important, for you to understand how my models are performing. So what do we need finally? I'm just condensing everything into these 4 boxes. We need a version control of where exactly my data is all about. Where did I source my data? How did the features get in? Where are my features stored? I should have this entire traceability there, the audit trail, and then I need to have the data dictionary to have the highest level of quality, and then the model traceability about model registry. So my conclusions are start early. Don't wait. Even if you have 10 rows of data for your machine learning model to begin with, start pretty early. And build your MLOps framework and your core drivers first. Without that, you're again going to go into a conventional DevOps kind of a mindset to build machine learning projects. That will not work. So build your MLOps framework and your core drivers first. Strengthen those CI/CD pipelines. So as part of your CI/CD, run your ISOT, Black, Pylint. Everything should be embedded as and when your code is being shipped as part of the CI/CD pipelines. Then let your team know about educate your team members, your data science team members about security-driven design thinking, on what circumstances that they need to apply. The one that we saw in one of those slides there, what every data science team should need to do. Then probe for sensitive data, because sensitive data is out there in one form or the other, and it is latent, and it is up to us to figure out where exactly it is hidden out there. Finally, model monitoring and explainability is very important, and because regulators will come and compliance and audits will come and ask you, but in my opinion it can wait, in the sense that not for too long, it can wait. If you have strengthened those security principles with going through a security architecture review in each and every stage of those pipeline, when the model has gone live, you can start building on your model monitoring and explainability there. Because you don't want to start on model monitoring and explainability if you have not taken care of some of those security things in the earlier stages of the pipeline. Finally, you don't need to stick to any one particular product. You can build your own SecMLOps. That's what we did. And we were able to address most of those questions as part of the audits, which came out of the DPIA assessments, for one of those projects that we did. And very similar to GDPR, it's about data protection and impact assessment. And most of the items, that you saw in the stock, pretty much stemmed out of that. And the good part was we embedded security much earlier, and we started thinking about it during the design phase. So we were able to take care of those questions. We did firefight a little bit after we went live, but it was not a cumbersome exercise for us. That's about it. Thank you. Some of my references I've quoted here, and some of my talks around explainability I've just listed out there. Thank you.